So in this video, I'll explain what is principal disjunction normal form and how to convert the given statement into a principal disjunction normal form. So we have already seen what is disjunction normal form and conjunction normal form. These principal disjunction normal form and conjunction normal form are the extension of those basic normal forms. So first here what is principal disjunction normal form is before explaining the definition of principal disjunction normal form. So first we will see what is min term. So principal disjunction normal form contains min terms. So that's why first let's see what is min term, what are the different possible min terms with some variables. What is min term is for a given number of variables, the min term consists of conjunctions in which each statement variable or its negation but not both appears only once. So here the min terms contains either the negation or normal negation of any variable or the variable only appears once, and those are connected by the conjunction. For example, if you take P and Q's two statements, then there are four possible min terms. So those are P and Q. Here both P and Q are normal variables. And second possibility is P and not Q. Here P normal variable and negation of Q. And in third possible one is not P and Q. P is negated and Q is normal. And the last possible fourth min term is both P and Q are negated and connected by the conjunction. So these are the four possible min terms with two variables P and Q. So if you have three variables P, Q, R, then you will get 8 possible min terms. So these are the different possibilities which we can apply to P, Q and R. If you observe here, first min term in first min terms all PQ are normal statements. So in second only negation is applied to R. In third negation is applied to only Q. And here in fifth negation is applied to only Q. And fourth one negation is applied to Q and R. And next we apply negation to P and R. And next we apply negation to only P and Q. And last one is negation of all the variables connected by conjunction. So these are the different min terms possible if we have two variables and if we have only three variables. So now let's see the definition of principal disjunction normal form. So for a given formula, an equivalent formula consists of disjunction of min terms. So min terms contains conjunction, and disjunction of min terms means within the brackets we have min terms connected by and outside the bracket we have only r's. Here we have two different methods to find out the principal disjunction normal form. So one is by using truth table and other one is by applying the formulas. So first let's see how to find out the principal disjunction normal form by using the truth table. So first step is construct the truth table. Then for every truth value of t only, so only wherever you have the truth values at t, for that combination we take the p and q values and we convert that p and q values into the min terms. Now apply the disjunction between the min terms. So these are the three steps we have to follow to find out the principal disjunction normal form by using truth table. For example, here find out the principal disjunction normal form of P condition Q. So P condition Q, we need to find out the principal disjunction normal form. First find out the truth table for P condition Q. So PQ So possibilities, and P condition Q means true, false, true, true. So this is the first step. First find out the truth table. Then take only the truth values. For the truth values of P and Q values, convert into the minterms. So in first row, P condition Q is true. What are the P and Q values? Both are true. So both are true means P and Q connected by AND. As minterms, in minterms the variables are connected by AND. And if you take the third row, what are the P and Q values? P is false. So as P is false, we take negation of P, and Q is true, so take Q. And in fourth row, P and Q both false, so take negation of P, negation of Q of AND. That means first row, third row and fourth row contains the truth values as true. So only take the terms of first, third and fourth rows and connected by the disjunction. So because a principal disjunction normal form means disjunction of minterms. Disjunction means OR. So take first, third and fourth minterms and connected by the OR. So this is the required principal disjunction normal. Let's see one more example. Obtain the principal disjunction normal form for this statement. So here in this statement contains three variables P, Q, R. So take P, Q, R statements. Means here you will get 8 possibilities. So first find out the whole statement truth value. First find out P and Q. Next find out not P and R value. Next find out Q and R value. And again find out the whole statement. So the different truth values are these. As we always took only the truth values means first 2 and 5th and 7th columns are taken, and these are the minterms related to that. So take first 2, 5th and 7th column minterms and connected by the disjunction. And this is how we find out the principal disjunction normal form by using truth values. And without constructing the truth values, how to construct the disjunction normal form is, so first step is replace a condition by the equivalent formula which contains and, or, and negation. And next find out, next if you can apply De Morgan's law, please apply De Morgan's law or distributive law. So if you follow these first two steps, means then the given statement automatically converted into the disjunction normal form. So means first step is first convert the given step into the disjunction normal form. So in disjunction normal form you will get only the elementary sums. So you won't get the minterms. So there wherever the which variable is missing, so in that place we add and t. So if we add and t to any statement, the statement the statement meaning is doesn't change. So that's why we include and t and again apply the distributive law. Then you will get the required principal disjunction normal form. For example, if you take this example, find out the principal disjunction normal form of this statement. And the first step is wherever you have condition statements or De Morgan's law can be applied, apply that. So first here we have condition statement. So first apply P condition Q means not P or Q. Again we have condition statement here. So apply condition statement formula not P of the whole thing. Then you will get this one. So next apply De Morgan's law. Here in the last part of the given statement, if you apply negation law, then you will get Q and P. Then again apply distributive law here, then you will get not P and Q and P followed by this. So this implies not P or this not P and P means false. False and Q means it becomes false, or P and Q. Q and Q is nothing but Q, so it becomes P and Q. So this whole thing becomes not P or P and Q. So now the given statement at this point converted into the disjunction normal form. So in the second term, the term is complete. It's a min term. But in the first term, it is not P. It's not a min term. So here, what missing here? Q missing here. So here we add and T. Instead of T, you can write it as Q or not Q. Q or not Q is nothing but T. So now if you apply distributive law, then you will get not P and Q or not P and not Q or P and Q. So now here everything is all are min terms connected by the disjunction. So this is the required disjunction normal form.